Building a human heart, it's like following an incredibly complex biological blueprint. But what happens when there's a typo, a mistake in that original design? Well, that's the core of congenital heart disease, and we're going to break down exactly what that means. So think about that for a second. What if your heart was built from a flawed blueprint? It's a pretty intense thought, right? But for millions of people, that's their reality. We're not talking about heart problems that develop later in life. This is about a structural issue that's there from day one. All right, so here's our game plan for this explainer. We'll start with the basics of this flaw, then we'll get into the puzzle of what causes it. We'll look at the two main ways things can go wrong: shunts and obstructions. Think of them as detours and roadblocks. And then we'll finish with the really hopeful part, the incredible story of survival into adulthood. Okay, first up, a flaw in the blueprint. Let's get right to the heart of it. What is congenital heart disease? So, congenital heart disease, or CHD, basically means there's an abnormality in the heart or the big blood vessels connected to it, and it's there right from birth. The key word here is congenital. It means you're born with it. We're talking about actual structural problems, like holes where there shouldn't be, valves that are too narrow, or arteries that are just in the wrong spot. It's not something you get later on. And you might think this is super rare, but it's really not. About 1% of all babies born worldwide have a serious congenital heart defect. I mean, 1%. That makes it one of the most common types of birth defects out there. So we're talking about millions of little hearts starting out with a really big challenge. Okay, so that leads to the million-dollar question, right? Why? Why do these mistakes in the blueprint even happen? Well, it's not a simple answer. It's more like a giant puzzle, with pieces from our genes and our environment all mixed together. And you have to see just how fast this all goes down. The heart's development happens in this ridiculously small window of time. We're talking between week 3 and week 8 of pregnancy. It all starts with just a few cells migrating, and by day 20, you've got a beating tube. By the end of week 8, the whole 4-chambered heart is pretty much done. It's an absolute sprint, and if anything goes wrong during that race, well, the consequences can be huge. So what are some of those puzzle pieces? Well, we know genetics are a big one. Sometimes it's a chromosomal thing, like with trisomy 21, also known as Down syndrome. Other times, it's a tiny mutation in a single gene. Then you've got environmental factors, like a rubella infection during pregnancy. Even nutrition plays a part. We know that getting enough folate, for example, can actually lower the risk. But here's the kicker, and it's pretty wild. For all that we do know, the precise cause is a total mystery in almost 90% of cases. 90%! It's kind of humbling, right? It just goes to show you how much we're still figuring out about those very first moments of life. All right, so let's get into what these flaws actually look like. They mostly fall into two big buckets. First up, shunts. Think of a shunt as an abnormal detour for your blood. And with these detours, the direction the blood flows is everything. So you've got left to right shunts. That's when oxygen-rich blood from the high-pressure left side of the heart gets pushed over to the low-pressure right side. The result? The lungs get totally flooded with way too much blood. Then you've got the opposite, right to left shunts. This is often way more serious, at least right away. This is when oxygen-poor blood from the right side bypasses the lungs completely and gets pumped straight out to the body. And that's what causes cyanosis, that bluish color in the skin. Let's take a look at a classic left-to-right shunt. This is a ventricular septal defect, or a VSD. It's actually the most common congenital heart defect. It's pretty simple, really. It's just a hole in the wall between the heart's two lower chambers. You can easily imagine how that high-pressure blood on the left side would just squirt right through that hole to the right side. Okay, so that was the diagram. Now look at this. This is a medical photo of a real heart with a VSD. That little opening right there, that's it. That's the actual flaw in the blueprint we've been talking about, creating that detour for the blood. All right, now for a classic right-to-left shunt. This one's called tetralogy of Fallot. It's a bit more complex. What's happening here is a whole combination of problems forces that blue, oxygen-poor blood to skip the lungs and go right out to the body. And that is what leads to cyanosis. Yeah, the name tetralogy literally means a group of 4. And that's because it's like a perfect storm of 4 different things going wrong at once. You've got that hole, the VSD we talked about. You've got a blockage that stops blood from getting to the lungs easily. The body's main artery, the aorta, is kind of sitting in the wrong spot, right over the hole. And finally, because of all this, the right side of the heart gets super muscular and thick from working way too hard. It's really a cascade of failures all happening together. Okay, so that was bucket number one, shunts or detours. Now for bucket number two, obstructions. And if a shunt is a detour, an obstruction is a straight up roadblock, a physical blockage stopping blood in its tracks. So, with an obstruction, the blood is trying to go the right way, but the path is just too narrow. Imagine a pipe that's been pinched. This can happen to a heart valve, inside one of the chambers, or in one of those major arteries leaving the heart. A perfect example of this is something called coarctation of the aorta. Now, the aorta, that's the main highway carrying blood from your heart to the rest of your body. With this condition, there's a serious pinch in that highway, a narrowing that creates a massive traffic jam for blood trying to get through. And the results are just basic physics, really. You get a traffic jam, right? So the pressure builds up before the jam. That means you get high blood pressure in your arms and head. But everything after the jam, well, it's just a trickle of traffic getting through. So you end up with low blood pressure and really weak pulses in your legs. It makes perfect sense when you think about it, but what's crazy is that milder cases can sometimes go completely unnoticed until someone is well into adulthood. So we've covered the flaws, the detours, the roadblocks. It can sound pretty grim, but that is not where this story ends, not even close. In fact, it's the beginning of a whole new chapter, one about amazing medical breakthroughs and, most importantly, about survival. And the absolute game changer here has been surgery. I mean, we're talking about incredible advances that have turned what used to be a death sentence into something that can often be fixed. Surgeons can now go into these tiny hearts, patch the holes, and open up the blockages. It's just amazing. And the result of all this? It's staggering. Right now, in the United States alone, there are an estimated 1.5 million adults living with congenital heart disease. Think about that. The very first kids who had these life-saving surgeries, they're adults now. They've grown up. And it's not a static number. That population of adult survivors is actually growing by about 5% every single year. It's just such a powerful statement about how far medicine has come. It means more and more kids aren't just surviving, they're thriving and making it to adulthood. But here's the thing, this amazing success story brings a whole new challenge with it, because a repaired heart isn't the same as a cured heart. These individuals need specialized care for their entire lives. So the big question for the medical world has shifted. It's not just how do we help them survive childhood anymore. Now it's how do we build a system that can provide a lifetime of care for this growing population of survivors who deserve to live long, full lives.